Howdy, I'm Ralph Tanner. I'm a professor of microbiology at the University of Oklahoma. I'm an applied microbial physiologist, and I've been using my skills for the last 10 years to work in bioenergy. For the EPSCoR project, we're working on figuring out how to convert carbon monoxide and synthesis gas to biobutanol. We can make ethanol from synthesis gas right now. Butanol, a little trickier, but if we can make butanol from synthesis gas, it's a product that's pipeline ready, automobile engine ready, without worrying about flex fuel or anything. Actually has a higher energy density than gasoline. Doesn't pick up water like ethanol does. A lot of advantages, but it's going to be a little bit more difficult to make. The conversion of synthesis gas to our alcohol products is by fermentation under anoxic condition, air-free conditions, using bacteria that are called acetogens. And it's a pretty interesting story. My first project as a graduate student was to work with acetogens. These are organisms that convert C1 compounds like carbon dioxide or carbon monoxide to C2 or higher products. They want to make acetic acid. We've tricked them to make ethanol instead, and now we're tricking them to make butanol instead of ethanol. Another side benefit is we discover new microbiology in these projects, and in the bioenergy project specifically, we've discovered two new genera. That's like discovering a whole new kind of whale, if you will. And of course, all of our microbial catalysts for the project are new species. The advantage of making this from carbon monoxide or synthesis gas is anything you can burn, we can convert into an alcohol. So we don't need sugars, we don't need starches, we don't need to do a lot of pre-treatment to biomass. We just do a partial burn of anything like be waste paper, old tires, wood, leftover straw from rice harvest, etc. And that's our substrate. Well, for the average citizen, and for myself for that matter, as an applied microbial physiologist, my goal is to have steel on the ground, making a product that can be used by people in the United States. If we are successful with the biobutanol project, we'll be producing something from biomass or waste materials that can go directly into a pipeline, that can go directly into an automobile engine at a price lower than current gasoline prices and without the need for importing oil. Research is a personnel-driven activity. It takes people. That's the most important part. It's also the most expensive part. And EPSCoR is providing a stable funding to focus on producing this next generation biofuel butanol.